Mahi, so we were solving problem number 61. Do you remember this? And we have reached to a state where we had to solve these two equations. Do you remember that, Mahi?
Yes, sir.
Yeah, and my calculator was in radian mode, and therefore yesterday जो मैंने P का answer दिया था, that was not correct. But now I have corrected that. If you solve these two equations by keeping your calculator in degree mode, you are going to get the value of P as 143.03 Newton and normal reaction as 504.52 Newton. Are you with me?
Yes, sir.
Okay. Uh, Now, so where were we? So let us look at this problem. So we were finding out minimum value of P that is required to maintain the equilibrium. अगर ये P की वैल्यू इस वैल्यू से भी कम हो जाए, 143.03 से कम हो जाए, तो क्या होने वाला है? The block is going to start sliding down. Are you with me?
Yes, sir.
So that's what we discussed, and therefore we say the motion is impending. In which direction? It is impending in downward direction. Are you with me?
Yes, sir.
The motion is impending in downward direction. Now, uh, next question. Now, next range that we have to find out is what is the value at P at which the blocks start sliding up. Are you with me? As I go on increasing the value of P beyond this 143.03, one stage will reach when the block will start sliding up. Do you agree with me?
Yes, sir.
Okay. Somebody inform Anushka Patil to include her roll number. Unless she does that, I am not going to let anyone in. Roll number hona hi chahiye. Now, so let us now consider a case where motion is impending in upward direction. Are you with me?
Yes, sir.
Okay. So now let us draw free body diagram. So what are going to be changes in free body diagram? All the forces are going to remain same, except for the fact that as the block is now about to move in upward direction, therefore frictional force that can be offered will be in downward direction. Do you agree with me?
Yes, sir.
Yeah. So all the other things, they remain same. Only the changes, the direction of this FR max is towards downward direction. Are you with me?
Yes, sir.
Now, what is its effect on equation of equilibrium? So the equation of equilibrium in normal direction is going to remain unchanged because we have changed direction of only that force which is in tangential direction, which doesn't have any component in normal direction. Do you agree with me?
Yes, sir.
So as this force doesn't have any component in normal direction, whether I change its direction or whether I maintain it in same direction, it is not going to matter for the equilibrium equation in normal direction. So the first equation remains as it is. So I have preserved the first equation as it is. Summation of all the forces in normal direction equal to 0. Are you with me?
Yes, sir.
Yeah. Now what is going to change is the second equation. That is summation of all the forces in tangential direction. Now as I have changed this Fr max direction in downward sense, therefore the only term that is going to change is this 0.25 times n. Its sign is going to be negative. Do you agree with me?
Yes, sir.
Fr max is mu s times normal reaction. So 0.25 times normal reaction is its magnitude. But as now the block is about to start ascending, therefore this Fr max must be in downward direction. That means it must be in negative t direction, and therefore this term only will become negative. So if you look at the equation here, the only change is this term becomes minus 0.25 times n. Are you with me?
Yes, sir.
So now if we solve these two equations simultaneously, we get the value of P is equal to 483.45 Newton. So this is the maximum value of P that can be there without sliding of block in ascending direction. इससे अगर आप ज्यादा करोगे P, the block is going to start sliding in upward direction. Happy?
Yes, sir.
And what was the earlier value of P? This is the minimum value of P required to stop sliding of a block in descending direction. अगर P की वैल्यू इसके नीचे आ गई तो द ब्लॉक इज गोइंग टू स्लाइड डाउन. आर यू विथ मी?
Yes, sir.
So what is the value of P? What is the range of P within which the block is going to be in equilibrium? That range is this one. P should lie anywhere between 143.03 Newton and 483.45 Newton. And the block can stay in equilibrium. Are you with me?
Yes, sir.
Happy? Have you understood this problem?
Yes, sir.
Exact same concept is there in second problem. So just to make you acquainted, I have also taken uh, one more problem of this sort. So let us have a look at this. So problem number 62. Can you read the statement for me, Mahi?
Yes, sir.
Yeah,
The
go ahead.
coefficient of friction between the block and the rail are US equals to 0.30 and mu k equals to 0.25. Knowing that theta equals to 65 degree, determine the smallest value of P required. A. To start the block moving up the rail. B. To keep it from moving down.
Just give me a minute. Yeah. So let us have a look at this solution. So case one, to start the block moving up the rail. ऐसे बोला है ना? Value of P required to start the block moving up the rail. So therefore, we say that the direction of impending motion is upward. हमें उस वो value of P चाहिए जिस at that value the direction of impending motion will be upward. If you increase P beyond that value, then the block is going to slide up. Do you agree with me?
Yes, sir.
Okay, so I am going to draw free body diagram. So what free the block from all external agencies. So I have to show this P. I have to show this 500 Newton. Do you agree with me?
Yes, sir.
Yeah. And then perpendicular to this rail, we are going to have a normal reaction that is shown as N. Happy?
Yes, sir.
And now which should be the direction of frictional force? As the block is about to slide up, the frictional force must act in downward direction. Happy?
Yes, sir.
So that I have shown Fr max in downward direction. I have called this direction normal to the surface of rail as N, and along the rail towards right is T. Are you with me? So there are two directions, N and T. Happy?
Yes, sir.
Now we are going to write down all the crux of this problem is writing down the equations of equilibrium, not in XY coordinate system, writing them down in N and T coordinate system. Are you with me?
Yes, sir.
So I need to find out angles made by all the forces with reference to N or T. Happy?
Yes, sir.
So what is the angle that P makes with horizontal? It is theta. But what is the value of theta? Theta is given as 65. Happy?
Yes, sir.
Now this angle is 65. But I want to find out the angle that P makes with this rail. Are you with me?
Yes, sir.
So I have drawn a line parallel to the rail from P. And what is it? What is the angle made by rail with reference to horizontal? That is 35. So what is the angle that P makes with rail? Theta minus 35. So 65 minus 35. That is 30. Do you agree with me?
Yes, sir.
So angle made by P with tangential direction is 30 degree. That I have marked. Now what is the angle that 500 Newton makes with the normal direction? Is the next question. तो अब जरा देखो हॉरिजॉन्टल के साथ रेल ने किया हुआ एंगल कितना है 35 डिग्री है. डू यू एग्री विथ मी?
Yes, sir.
सो देयरफॉर 500 न्यूटन मतलब वर्टिकल के साथ हॉरिजॉन्टल को परपेंडिकुलर वर्टिकल वर्टिकल के साथ रेल को जो नॉर्मल डायरेक्शन है रेल को जो नॉर्मल डायरेक्शन है. आर यू विथ मी?
Yes, sir.
दिस इज नॉर्मल डायरेक्शन टू द रेल. उसने किया हुआ एंगल भी 35 रहेगा because angle between the lines is same as angle between their perpendiculars. Are you with me?
Yes, sir.
अगर डिफिकल्ट है तो मुझे फिर से बताता हूं. See, this is horizontal. 500 Newton is vertical. So horizontal और vertical में angle कितना है? 90 degree. Are you with me?
Yes, sir.
And now this is along the rail and this is perpendicular to the rail. So along the rail or perpendicular to the rail में angle कितना है? 90 degree. So angle between the perpendiculars drawn to the line must be equal to angle between the lines. So this angle also must be 35. Do you agree with me?
Yes, sir.
So I have shown angle made by 500 Newton with normal direction as 35. Happy?
Yes, sir.
So this is the crux of the problem. You should be able to identify correctly angles made by various forces with reference to normal and tangential direction. Are you with me?
Yes, sir.
Okay. Now, so let us now write down summation of all the forces in tangential direction equal to 0. Equation of equilibrium. Why can I apply equation of equilibrium? Because though the motion is impending, it is yet to begin, and therefore the body is in equilibrium. Are you with me?
Yes, sir.
So therefore I apply equation summation f of ft equal to 0. That gives me what? देखो p cos theta, p cos 30. Happy? P cos 30.
Yes, sir.
It is positive because it is in positive tangential direction. Minus 500 sin 35. You can see its component is going to be in negative tangential direction.
Yes, sir.
Not tangential, I'm sorry, negative t direction. Right?
Yes, sir.
And then frictional force Fr max is also in negative t direction, but its value is coefficient of static friction multiplied by normal reaction. So that is 0.3 times n. Do you agree with me?
Yes, sir.
Mind you, the data given about coefficient of kinetic friction is invalid here, not required, because the motion is still impending. The motion has not begun. Are you with me?
Yes, sir.
So therefore, P cos 30 minus 500 sin 35 minus 0.3 n is equal to 0. Happy?
Yes, sir.
Rearrange the terms. Constant term on right hand side, unknowns on left hand side. P cos 30 minus 0.3 n is equal to 500 sin 35. Now next equation, summation Fn equal to 0. So let us apply summation Fn equal to 0. P sin 30. Happy?
Yes, sir.
Minus 500 cos 35 plus n equal to 0. P sin 30 minus 500 cos 35 plus n equal to 0. Happy?
Yes, sir.
Do the same trick. Constants on other side, unknowns on one side. P sin 30 plus n is equal to 500 cos 35. In equation number 1 and 2, only unknowns are p and n. Solve for p and n. You will get p equal to 403.19 Newton. So what is the value of p required to start the block moving up slightly greater than 403.19 Newton? Are you with me?
Yes, sir.
Or in other words, it is the smallest value of p required to commence the motion. Happy?
Yes, sir.
हाँ. अब इस प्रॉब्लम के वर्डिंग में थोड़ी सी गड़बड़ है. क्या गड़बड़ है वो मैं बताता हूँ. When we start part B, what is the wording? Tell me. What is the value of p required? Smallest value लिखा है. That is the problem. We will see how why. What is the smallest value of p required to keep it? अच्छा, नो, द वर्डिंग इज करेक्ट. टू कीप इट फ्रॉम मूविंग डाउन. इसका मतलब है कि ये मूव डाउन ना हो, इसके लिए कितनी वैल्यू ऑफ पी जरूरी है? आर यू विथ मी?
Yes, sir.
So let us try solving that problem. So what is going to change? Now the block is about to move in downward direction. So therefore, only the direction of frictional force is going to be upward. That's the change in free body diagram. Do you agree with me?
Yes, sir.
Yeah. So look at free body diagram for case B. What is the direction of impending motion? The block is about to slide down. Therefore, direction of impending motion is shown as downward. Happy?
Yes, sir.
Naturally, therefore, the maximum frictional resistance that is offered is going to be in counter direction. It is upward. What is the change? Summation of f of t, the sign of this force instead of negative is going to now become positive. Happy? ये जो निगेटिव था, that's only the change. Do you agree with me?
Yes, sir.
And what happens to other equation? It doesn't change because you have changed something in tangential direction. It will not affect the equation in normal direction. Happy?
Yes, sir.
Okay. So if we solve now these two equations, we get the value of P as 228.92 Newton and N as 295.11 Newton. So this is the largest value of P to keep the block moving in downward direction. But ये do you understand that? P की वैल्यू
Yes,
इससे
sir.
कम है तो उस वैल्यू में ब्लॉक विल कंटिन्यू मूविंग डाउन, but that we will put it in the wordings that have been asked in the problem. It is the smallest p required. This is the smallest p required to not to move the block, not to move the block in downward direction. Do you agree with me?
Yes, sir.
Have you understood this problem now? These two problems
Yes,
are
sir.
identical. ये पहले वाला problem and this problem is identical. Are you with me?
Yes, sir.
Now comes an interesting problem. This is problem number 63 that we are now going to solve. Just give me a second. Pardon me, there is also an exam going on for MTech students for which I am coordinating. So I have to send a message there. So I will pause. Okay, so let us resume. Can you read the problem statement for me, Mai?
The coefficient of friction are mu s equals to 0.40 and mu k equals to 0.30 between all surfaces of contact. Determine the smallest 4p required to start 30 kg block moving if cable A is attached as shown, B is removed.
So we have two problems in hand. In fact, here one problem is there in which the cable AB is attached, and other problem is there where cable AB is not attached. And what do we have to find out? The smallest value of P that will start the motion of 30 kg block. Do you agree with me?
Yes,
This
sir.
is what it means. Now let us look at case A. So if block B block of 30 kg has to start moving in left direction, you will understand that if the cable is attached, the block of 20 kg must move towards right. Do you agree with me?
Yes, sir.
And now imagine that the cable is removed. If cable is removed, the moment 30 kg block starts moving towards left, 20 kg block will be carried forward with it. Do you agree with me?
Yes, sir.
That's the difference. Now, this physical difference, how does it transcend itself into the mathematical equations and free body diagram that we are going to see? Part A, free body diagram of upper block. I am going to now draw free body diagram of upper block first. So for upper block, what are the external agencies? Is the earth external agency? Yes. So its gravitational force, should it be shown? Yes. Is the information required to show gravitational force is given? Yes. Therefore, I am going to show the gravitational force acting on the block as 20 into 9.81. Do you agree with me?
Yes, sir.
Okay. What else is external? This string is external. So I must give a cut here and I must show what the string must have been doing. The string can only pull the block. There is no other way. String cannot apply compression. Do you agree with me?
Yes, sir.
So therefore, this is the tensile force that I have shown. Happy?
Yes, sir.
Now you have to understand that uh, when the 30 kg block starts moving in the direction of P, the direction of impending motion for block of 20 kg is going to be towards right. Do you agree with me?
Yes, sir.
तो अब जरा यहाँ पे ध्यान दो, block of 20 kg has a impending motion towards right when block of 30 kg is about to move towards left. And you are now drawing the free body diagram of 20 kg block. So you are interested in frictional force exerted by 30 kg block on 20 kg block. Do you agree with me?
Yes, sir.
Huh. So when you are interested in finding out external force, frictional force exerted by 30 kg block on 20 kg block, you must station the observer on 30 kg block. Do you agree with me?
Yes, sir.
So observer is now standing on 30 kg block. He is about to move towards left. So with respect to him, the block of 20 kg will move towards right. Is about to move towards right. Do you agree with me?
Yes, sir.
Therefore, the frictional force must be in the opposite direction. Happy?
Yes, sir.
रिलेटिव इंपेंडिंग मोशन के डायरेक्शन के अपोजिट डायरेक्शन में एफ आर मैक्स दिखाना है. एंड the reaction offered by 30 kg block normal to the surfaces in contact, that I am going to call it as N1. Are you with me?
Yes, sir.
What is N1? N1 is the reaction offered by 30 kg block on 20 kg block, which is perpendicular to the surfaces in contact. Happy? Happy?
Yes, sir.
Mahi, are you there?
Yes, sir.
Yeah. So now this is N and this is FR max. Now as the motion is impending, that means it has not yet commenced. Therefore, I can write down the equations of equilibrium. I can write down the equation of equilibrium in x direction and y direction. So summation fx equal to 0 gives me what? Fr max minus Fr max plus t equal to 0. Do you agree with me?
Yes, sir.
So T is equal to Fr max. But what is Fr max? Fr max is nothing but coefficient of static friction. Why? Because the motion has not started. So coefficient of static friction 0.4 multiplied by N1. Agreed?
Yes, sir.
So minus 0.4 times N1 plus T equal to 0 gives me T is equal to 0.4 times N1. Happy?
Yes, sir.
Now summation Fy equal to 0. N1 minus 20 into 9.81 equal to 0. Don't take G as 10. That is the simplification that you are used to do in 11th and 12th standard physics. Not here, unless it is specified. Are you with me?
Yes, sir.
So N1 minus 20 into 9.81 equal to 0. Therefore, N1 is equal to 20 into 9.81 Newton. Kg meter per second square is Newton. Do you agree with me?
Yes, sir.
So N1 is equal to 20 into 9.81. This is the first part. Now we are going to draw free body diagram of a lower block. So lower block के ऊपर क्या क्या external है? Is earth external? Of course. So what is the force exerted by earth on this block? 30 into 9.81. Do you agree with me?
Yes, sir.
Now, if block of 30 kg is applying reaction N1 on block of 20 kg, the block of 20 kg must be applying a force of same magnitude but opposite sense on block of 30 kg by Newton's third law. Do you agree with me?
Yes, sir.
What is N1? 20 into 9.81. So that needs to be shown with the reversal of direction. Here N1 is upward. Here N1 is going to be downwards. 20 into 9.81. Do you agree with me?
Yes, sir.
Is P external? Yes, P is applied by external agency on the lower block. So therefore I must show P as well. And now there are going to be frictions at two locations. One here and one here. Do you agree with me?
Yes, sir.
Now, station the observer on 20 kg block. With reference to observer on 20 kg block, the block of 30 kg is going to move towards left. And therefore, this 20 kg block must apply a frictional force towards right. Do you agree with me?
Yes, sir.
So this is Fr max that is applied by 20 kg block when the motion is impending. Now, what is the direction of impending motion for lower block? Lower block direction of impending motion is towards left. Are you with me?
Yes, sir.
Mind you, I am using a category. I am categorically using the word impending motion. That means that motion has not yet begun. But if it has to occur, it will occur towards left. Are you with me?
Yes, sir.
Now, now station the observer on this surface. With reference to this surface as well, the 30 kg block is moving towards left. Therefore, this surface also must offer equal and opposite reaction and I'm going to call that as FR1 max. It is going to be different than FR max. What is FR max? That we have already evaluated in the previous diagram. What is the value? Tell me. 0.4 times N1. 0.4 times 20 into 9.81. Happy?
Yes, sir.
Now, this FR1 max will be how much? That will be equal to 0.4 times N2, where N2 is the normal reaction offered by this floor on a block of 30 kg. Do you agree with me?
Yes, sir.
And you are also going to show, you are going to cut this string here because string is external to the block and it must be pulling the block with amount tension T. Do you agree with me?
Yes, sir.
Why these two tensions are same? Because the pulley is not locked. This pulley is not locked. Not locked का मतलब क्या है? It is it is allowed to roll without any friction. Are you with me?
Yes, sir.
When that happens, we will see successively that when there is a smooth pulley or there is unlocked pulley, at that time tension in this part of the string will be same as tension in this part of the string. Are you with me?
Yes, sir.
So therefore that tension T is also to be shown, that the string must be pulling the block by tension T. Happy?
Yes, sir.
But how do we have the value of this tension T? Yes, we have already obtained it in here. That is 0.4 times N1. What is N1? 20 into 9.81. So what is the value of tension T? 0.4 times 20 into 9.81. Happy?
Yes, sir.
So now apply summation Fy equal to 0. That gives me the value of N2. Because in Fy direction, there are only two forces. N2, 20 and 30. So N2 minus 20 into 9.81 minus 30 into 9.81 must be 0. That means N2 must be equal to 20 plus 30 into 9.81. Happy?
Yes, sir.
Okay. Now apply summation Fx equal to 0. Summation Fx equal to 0 gives you minus P plus 0.4 into 20 into 9.81. This force plus this one. What is this force? That I have already told you. That is mu s times N2. Do you agree with me?
Yes, sir.
Mu s is 0.4. And what is N2? N2 is 50 into 9.81. Do you agree with me?
Yes, sir.
And then we have to also write down T. So what is the value of T? Value of T is already established here. It is 0.4 into 20 into 9.81. Happy?
Yes, sir.
This must be equal to 0. So if you simplify, you get P as 353.16 Newton. So for any value of P slightly greater than 353.16 Newton, the block of 30 kg is going to commence its motion towards left. Happy?
Yes, sir.
And now let us look at the second part. What if this string is removed? So this tension is going to be absent. Do you agree with me?
Yes, sir.
And there is one more thing. As the block of 30 kg starts moving towards left, there is nothing to pull 20 kg towards right. यहाँ पे कैसे था? As the block of 30 kg starts moving towards left, as the length of string is constant, block 20 kg is bound to move towards right. Are you with me?
Yes, sir.
But अब यहाँ पे ऐसा कोई restriction नहीं है. The moment I remove this cable AB, the block starts moving towards left. 20 kg block will be also taken along. Are you with me?
Yes, sir.
And now there is no necessity of computing tension because it is absent. There is no string at all. Are you with me?
Yes, sir.
So अब जरा strategy देखो. When I am solving the part B of this, I am going to draw. I am sorry. When I am solving the part B of this, I am going to draw the free body diagram of both the blocks together as a body. Are you with me?
Yes, sir.
Both the blocks together as a body. Is Earth external? Yes. Should I be showing what Earth must be doing? Yes. So Earth must be applying a combined gravitational force of magnitude 50 into 9.81. Do you agree with me?
Yes, sir.
And there must be a normal reaction offered by this floor on these two blocks. Do you agree with me?
Yes, sir.
Then there is force P, and then there is maximum frictional resistance that can be offered in this direction. Do you agree with me?
Yes, sir.
What is the direction of impending motion of these both blocks? It is towards left. So frictional force must be offered towards right. Summation Fy equal to 0. As the motion is impending, I can still apply equations of equilibrium. Summation Fy equal to 0 gives me what? It gives me normal reaction N must be equal to 50 into 9.81 Newton. Happy?
Yes, sir.
And summation Fx gives me P minus Fr max must be equal to 0. Happy?
Yes, sir.
So that gives me P equal to Fr max. But what is Fr max? Fr max is nothing but coefficient of static friction multiplied by normal reaction. Normal reaction we have already evaluated as 50 into 9.81. So P is equal to 196.2. Are you with me?
Yes, sir.
So when this string is not attached, it is very easy to move 30 kg blocks. 30 kg block. Are you with me?
Yes, sir.
Because when string was attached, what was the minimum force required? 353. When strings are not attached, what is the minimum force required? 196.2. Are you with me?
Yes, sir.
So this problem also tells us if in your life you don't have strings attached, it is very easy to move on. Now let us go to the next problem, problem number 64. Can you read the statement for me?
A 6.5-meter ladder AB leans against a wall as shown. Assuming that the coefficient of static friction μs is 0 at B, determine the smallest value of μs at A for which equilibrium is maintained.
हाँ, अब ये प्रॉब्लम थोड़ा सा weird है because you don't see any external force that is going to disturb the equilibrium. Do you agree with me?
Yes, sir.
So what must be the external force that will try to slide the ladder down? मतलब देखो इक्विलिब्रियम नहीं है मतलब क्या होने वाला है? This end of this ladder will go on sliding like this, and the ladder will go on becoming flat, and it will fall flat on the ground. This is loss of equilibrium. Do you agree with me?
Yes, sir.
But there is no one standing on the ladder. Where is the external force? बताओ. Are you able to catch my point?
Yes, sir.
There has to be an external force. Then only we can talk about whether the ladder is in equilibrium or not. So देखो यहाँ पे कुछ भी mention नहीं किया है अर्थ के बारे में, self weight के बारे में, but there is only one force that will try to topple this ladder down, or that will try to bring this ladder down, and that is its self weight. Do you agree with me?
Yes, sir.
So therefore, implicitly, not directly, but implicitly, it has been told to you that in free body diagram, you must show self weight. Are you with me?
Yes, sir.
हाँ, तो अब जरा देखो ये दिया नहीं रहता तो भी चलता 6.5 मीटर लैडर. Why? Because you have been given dimensions 6 and 2.5 meter. Are you with me?
Yes, sir.
So you can't you calculate the length of the ladder by Pythagoras theorem easily? So therefore this data is pampering. ये दिया नहीं होता तो भी चलता. Are you with me?
Yes, sir.
Now let us draw the free body diagram of the entire ladder. So how do we draw the free body diagram of ladder? किसका ड्रॉ करना है फ्री बॉडी डायग्राम? लैडर का. So what is external to the ladder? Is earth external? Yes. So should I be showing what the earth must have been doing? Yes. It must be applying a gravitational pull of equivalent amount of its self weight. Do you agree with me?
Yes, sir.
And where does that self weight act? At the center of gravity. Where is the center of gravity of ladder? Exactly at the mid length. We assume that the ladder is made up of equally spaced steps and it has uniform material throughout. ये सब assumptions है. Are you with me?
Yes, sir.
So with this assumption, I must say that the self-weight must pass through the center of gravity, and that center of gravity is going to be at the mid length of the ladder. Happy?
Yes, sir.
So this is at 3.25 meter and this is at 3.25 meter. What else is given? Tell me. Assuming that the coefficient of static friction mu(s) is 0 at B, that means this vertical wall is smooth. That is what is given. Are you with me?
Yes, sir.
If vertical wall is smooth, it cannot offer any reaction parallel to the wall. Do you agree with me? Imagine that you are walking on the floor where oil has been spilled. क्या होगा? It cannot offer any horizontal reaction. The moment you start walking, you are pushing the earth back, but earth will not be able to apply the force in front direction on you because of oil. Coefficient of static friction being 0, you will fall down. Are you with me?
Yes, sir.
So therefore, if the wall is smooth, it cannot offer reaction tangential to it or reaction along its surface. So we know for sure at B there cannot be reaction along the wall. Do you agree with me?
Yes, sir.
But that doesn't bother wall in offering the reaction normal to the wall. Are you with me? Dekho, even if oil is there on the surface, you can fairly stand there. There is no point, there is no problem in standing there. The moment you start walking, you will fall. Are you with me?
Yes, sir.
Why can you stand? Because the floor will still be able to offer the upward reaction normal to it. Similarly, as the surface is smooth here and it is vertical, there cannot be any vertical component of the reaction at B, but there will be horizontal reaction. And that reaction I have shown and I have called it as RB. Are you with me?
Yes, sir.
Carefully understand the philosophy. Any smooth surface cannot offer reaction along the surface, but it can very well offer reaction normal to it. Are you with me?
Yes, sir.
Imagine that this is smooth surface. I am looking at this point. So कौन से direction में reaction offer हो पाएगा? It is not necessarily an arc of circle. So what you have to understand? You have to draw a tangent to this curve here, and then this is the normal. Are you with me? This is normal.
Yes.
This is tangential direction. If this surface is smooth, it cannot offer any reaction in tangential direction, but it can very well offer reaction in normal direction. Are you with me?
Yes, sir.
Okay, I think I have made myself pretty clear. Now let us look at the other point. However, at A, the coefficient of static friction is non-zero. So that means the floor is rough. Are you with me?
Yes, sir.
Wall is smooth, but the floor is rough. And now in this case, you are going to have to, अब जरा देखो contact में कौन क्या है? Are there two surfaces in contact or is there a line and surface in contact? This is line. Do you agree with me?
Yes, sir.
Or probably for ladder it is a point. That point is in contact with this surface which is rough. Are you with me?
Yes, sir.
So there are two reactions that are going to be offered. One normal reaction. Normal to what? Normal to surfaces in contact. But here one surface is a point. So therefore normal reaction must be offered to perpendicular to the other surface. So rough surface को perpendicular जो reaction है उसको मैं बोलने वाला हूँ normal reaction Na. Do you agree with me?
Yes, sir.
It is normal reaction at A. Now what is the maximum frictional resistance that can be offered by, that is mu(s) times Na. Do you agree with me? This is maximum frictional resistance that can be offered. Happy?
Yes, sir.
Mu(s) times N. Now tell me what should I do? Now I am going to apply equations of equilibrium because I am interested in finding out smallest value of mu(s) at which equilibrium is possible. Do you agree with me?
Yes, sir.
So I assume that mu(s) is that value for which equilibrium very well prevails. In this sense, the ladder is now exhibiting an impending motion. देखो mu(s) अगर बहुत ज्यादा है तो there is no motion at all. mu(s) जैसे 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 कम होते जाता है, at a particular value of mu(s), this ladder is now about to slide. Are you with me?
Yes, sir.
Uh, that value of mu s I have shown here. So this itself is the minimum value of mu s at which the motion is impending. कौन से direction में impending है? A is going to move in this direction. Impending motion. Happy?
Yes, sir.
जरा समझो, theoretically बहुत, conceptually बहुत important है. For any value of mu s greater than this, motion will not be impending and frictional force will not be mu s times na, because mu s times na is the equation, law of friction, to be used only when motion is impending. Are you with me?
Yes, sir.
And for any value of mu s less than this value, the motion would have already begun, and therefore I will have to consider coefficient of kinetic friction and not static friction. Equilibrium would have been lost then. Are you with me?
Yes, sir.
So I am writing down this mu s as the minimum value of coefficient of static friction that compels the ladder to be on the verge of sliding down under the action of W. Happy?
Yes, sir.
Okay. I think this is fair enough. I have explained as much as I can. If any one of you have a doubt, please ask me. Now, so this you have to understand, this itself is the minimum value of mu s at which the motion is impending. If it is so, can I apply equations of equilibrium? Yes, because motion is still impending. Which equation of motion should I apply now? Now I should apply intelligently summation of moments of all the forces about A equal to 0. That will give me RB in terms of W. Do you agree with me?
Yes, sir.
So if I apply that, now can you tell me what is the moment of this W about A? So it is going to be 3.25 cos of this theta, but that is not required. Why not required? Because if you construct two triangles, triangle AB and this wall, and then this smaller triangle, they are similar triangles. So this distance is going to be 1.25. Happy?
Yes, sir.
Total is 2.5, uska half. So therefore, 1.25 into W. What kind of movement it is? Clockwise or anti-clockwise? Tell me.
Clockwise.
Yes. So I have to write it as W into 1.25 clockwise moment. Therefore minus. Happy?
Yes,
And
sir.
RB का moment कितना है? A के about? RB is horizontal. So I am interested in vertical distance between A and B, and that is 6 meter. So it is going to be RB into 6. Happy?
Yes, sir.
And it is anti-clockwise, so it is positive. So this turns to be 0. So therefore RB must be equal to, tell me how much? 1.25 by 6 into W. Happy?
Yes, sir.
And it has turned out to be positive. Therefore, originally assumed sense of RB is correct. Happy?
Yes, sir.
This still doesn't answer us the question that we have asked. Are you with me? I am interested in finding out the value of mu s. Do you agree with me?
Yes, sir.
So what is the next equation that I should use, which will involve mu s? Bolo? Summation Fy or summation Fx?
Summation fx.
Yes, because in summation Fy, mu s is not going to appear. So that equation, though valid, why to waste time? So I will use next equation, summation Fx equal to 0. Are you with me?
Yes, sir.
And what does that give me? Mu s times Na. Happy?
Yes, sir.
Minus Rb. Minus Rb must be equal to 0. But that indicates mu s is equal to Rb upon Na. Do you agree with me?
Yes, sir.
And now I need to find out what is the value of Na. The moment I ask myself question what is Na, I am left with no other option than using summation Fy. Are you with me?
Yes, sir.
So if I apply summation Fy equal to 0, what do I get? Tell me.
Na minus w.
Na minus W is equal to 0. So what is Na? Tell me.
W.
W. Now I substitute RB and Na values in this equation. You substitute both the values here. What do you get? Mu s is equal to 1.25 by 6 times w upon w. So it is 1.25 by 6. So how much is that? Tell me.
0.208.
0.208. There are few fascinating facts to be observed. Whatever may be the weight of ladder, it is not going to matter as far as the geometry remains same and coefficient of frictions remains same. Are you with me?
Yes, sir.
So whether the ladder is of 10 kg, whether it is of 20 kg, whether it is of 30 kg is immaterial. Weight cancels out. Do you see? Do you see?
Yes, sir.
Yeah. So what is the value of minimum coefficient of static friction required to maintain the equilibrium? 0.208. So if the coefficient of static friction of a floor is less than 0.208, then the ladder is going to slide down. If the coefficient of static friction is exactly equal to 0.208, the ladder is on the verge of sliding down. And if the coefficient of static friction is greater than 0.208, then the ladder is not going to slide. It is not under impending motion. Are you with me?
Yes, sir.
Fairly easy. अरे कुछ तो बोलो.
Yes, sir.
Yeah. Now let us go to the next problem. Problem number 65. So we will start solving this problem. Let us see how much we can reach till 10:30. We are going to have an extra lecture today and it is going to be at 3:30. Are you with me?
Yes, sir.
So 3:30 to 4:30 we are going to have an extra lecture where we will continue where I am going to start with the dynamics. Are you with me?
Yes,
So
sir.
I'm going to now conduct few extra lectures where I will start with dynamics and in our regular schedule, we will continue with statics. Please bear with me for some
Sir,
time. Yeah, go ahead.
so we have practicals at 3:30.
Which batch?
So N4.
No, but your practical slot is from 1:30 to 4:30, right? So by 3:30, I expect it will be over. No?
I think it will be over, but we are not sure.
Who is the faculty member?
Sanjay Rumde.
Okay. So can you just put a message to him and can you confirm to me on my personal WhatsApp that you whether you will complete by 3:30 or not?
Okay, sir.
Just ask him, is it possible for me to take the extra class at 3:30?
Okay, sir.
Which batch is this?
N4, sir.
In 4. So if not, then we will have to go take it at 4. Are you with me? So my based on the response that I received from N4 batch, either we will meet at 3:30 or we will meet at 4. By the way,
Oh,
N1 also has a mechanics practical today, which I am conducting, and we are going to do that from 2:15 to 3:15. Are you with me? N1 batch, anyone there?
Yes.
Okay, so N1 batch, please note, I will share the link. Today we will meet from 2:15 to 3:15. Then you will have 15 minutes break. And then at 3:30, we are going to start with the extra class. 3:30 or 4, let us see. So now, Mahi, can you read the statement for me?
the cylinder shown is of weight W and radius R, and the coefficient of static friction μs is same at A and B. Determine the magnitude of the largest couple M that can be applied to the cylinder if it is not to rotate.
Yes. So we have to determine the magnitude of largest couple M that can be applied to the cylinder if it is not going to rotate. That means it is on the verge of rotation. That's what we have to find out. So what is the maximum value of M at which the impending motion, देखो, impending motion is going to be in this direction. Do you agree with me?
Yes, sir.
Yeah. So let us now draw a free body diagram of this sphere. Is it a sphere or is it a ring? क्या लिखा है? cylinder. So let us draw the free body diagram of cylinder. चलो कैसे ड्रॉ करूं फ्री बॉडी डायग्राम, टेल मी. सो सिलेंडर का वेट W दिया है प्रॉब्लम में, सो वी हैव टू कंसीडर इट. सो इज अर्थ एक्सटर्नल टू द सिलेंडर? यस. शुड आई बी कंसीडरिंग इट्स वेट? यस. सो दैट आई एम गोइंग टू शो इट एज W. आर यू विथ मी?
Yes, sir.
Now at B we are going to have normal reaction. अब जरा देखो फिर से कोशिश करते हैं. At A and at B there are two surfaces in contact. Do you agree with me?
Yes, sir.
One is this vertical wall at A and this sphere at A. So if I draw tangent to this sphere at A, it is going to be this vertical wall itself. Do you agree with me?
Yes, sir.
If I draw tangent to the sphere at B, it is going to be this floor itself. Do you agree with me?
Yes, sir.
So normal reaction at B and normal reaction at A must be offered perpendicular to the floor and wall respectively. Do you agree with me?
Yes, sir.
Now, do all these forces pass through the center? Yes, obviously. And therefore, this forms a concurrent force system. Do you agree with me?
Yes, sir.
But now, we have not shown the frictional forces. Where do the frictional forces act? Frictional forces are going to act at these locations. As the direction of motion of impending motion is this way, therefore I am going to station the observer on floor and on wall. Are you with me?
Yes, sir.
As this sphere moves in this direction, the frictional resistances must be offered in tangential directions at these two locations and in this fashion. Do you agree with me?
Yes, sir.
So therefore, these frictional resistances, I am going to call them as Fr max 1 and Fr max 2. Do you agree with me?
Yes, sir.
Array Fr max 2. And now, so what should we do now? What else is pending? I also have couple moment M here. In free body diagram, I should also show M. Do you agree with me?
Yes, sir.
And now, if I take summation of moments of all the forces about center of the cylinder, that should be equal to 0 when the motion is impending. Do you agree with me?
Yes, sir.
Now, can you tell me what is the moment of W? 0. Do you agree with me?
Yes, sir.
What is the moment of, अरे मैंने यहाँ पे WA लिखा है, this has to be NA. Are you with me?
Yes, sir.
So I will write it as NA. NA and NB, they are passing through the centroid, so no moment. Do you agree with me? They are passing through the center, so they don't cause any moment. Happy?
Yes, sir.
So Fr1 max, this causes the moment, clockwise moment. Do you agree with me?
Yes, sir.
And what is the diameter? Radius is R, so it is into R. Do you agree with me? How much is this distance? R. Similarly, we have minus Fr2 max causing a moment of this magnitude clockwise, and we have acting moment M. This must be equal to 0. Happy?
Yes, sir.
So what must be equal to M? M must be therefore equal to Fr1 max. But what is Fr1 max? It is nothing but µs times Na into R. Do you agree with me?
Yes, sir.
And what is Fr2 max? It is nothing but µs times Nb into R. Happy?
Yes, sir.
So in fact that M is going to be equal to µs times Na minus µs times, sorry,
So it should be plus.
plus, yeah. So µs times R times Na plus Nb. This is going to be equal to m. Do you agree with me?
Yes, sir.
So I am now left with calculation of Na and Nb in terms of W. Are you with me?
Yes, sir.
So how do I do that? Summation Fy equal to 0 gives me what? Tell me. W,
Uh,
W,
and
W,
plus minus W plus NB.
minus W plus NB. Acha, how do you forget this? FR1 max
Yes, sir.
plus FR1 max. But what is FR1 max? Mu S times Na. Do you
Yes, sir.
agree with me? Do you agree with me?
Yes, sir.
This must be equal to 0. Happy?
Yes, sir.
So what does that give me? Mu S, is it given there? Mu S is same for all. So mu S is known quantity. Happy?
Yes, sir.
So mu S is known quantity. So unknowns here are only Na and Nb. So I get first equation. Mu S times Na plus Nb must be equal to W. Are you with me?
Yes, sir.
W is known quantity. Mu S is known quantity. Only unknowns here are Na and Nb. Happy?
Yes, sir.
Now what next? Summation Fx must be 0. So what does summation Fx equal to 0 give you? N1 minus
F2.
mu
FR2.
S times Nb. Happy?
Yes, sir.
And by the way, I should call it as Na. I'm sorry. Not N1, Na. Na minus mu S times Nb equal to 0.
No.
Do you agree with me?
Yes, sir.
So how much is Na?
Mu S
Na is
times.
equal to mu S times Nb. Substitute that in equation number 1. So what do I get? Mu S times mu S square. देखो mu S square times Na times Nb plus Nb is equal to W. Happy?
Yes, sir.
So how much is Nb? Tell me. W upon
Mu S square
1
plus 1.
plus mu S square. This is the value of Nb. Substitute this value of Nb here and substitute the value of Na there as well. How much is Na? So therefore Na is equal to how much? Tell me. W mu S times 1 upon mu S square. Happy?
Yes, sir.
So substitute these values of Na and Nb here. What do we get? M is equal to, tell me, mu S
Um,
times R into Na plus Nb. So Na plus Nb is W plus W into mu S upon 1 upon mu S square. 1 plus mu S square. Do you agree with me?
yes, sir.
So how much is that? W if I take common into bracket. Anyway, now I think you are mature enough to simplify. So this is our answer. Happy?
Yes, sir.
So this is problem number 65. In the next class, we will start with this problem number 66. Sure. So let us stop here today. We are going to meet in the afternoon, either at 3:30 or 4, depending upon N4 batch schedule. I request N4 batch students to inform me as early as possible. Happy? Okay, Mahi?
Yes, sir.
या किसी को कुछ डाउट है तो पूछो, otherwise we are going to close. Write down your name, roll number in chat box and then you can leave.
Sir. Sir.
Hello, I am reading the message as Spruha ma'am has postponed the lecture. Is it true?
Yes, sir. But today we have EC practical, sir. Till 4:30.
Okay, no problem. So anyway, now this lecture slot is off you, right? Spruha ma'am's.
Yes, sir.
Yes, sir, 10:45 is off.
Okay, so shall we continue? Means I will give you a break of 15 minutes and then I will take the that slot. Hmm?
Okay, sir,
Okay.
no problem.
Okay.